Hello and welcome to the stream. So everything should be fine and online, hopefully. Right. So this weekend will be mostly about cleaning up the things I did last weekend. So last weekend I worked on refactoring our core algorithms, and that all ended up in the Sudoku algorithms.h. And basically for this weekend I kind of have a couple of things in mind. So I should still improve the tests for the finfish, because that's a very complicated rule and keep running into weird corner cases there, so having more tests would be nice. But that's not super high priority. So what I definitely want to do is make set generation and number generation more clean. That's a very fuzzy thing to say, but basically right now we keep doing this while next bit whatnot loop, and I must admit I really don't like this. This is like it's a very verbose, it's easy to make a mistake. What I would really like is to have kind of a range for loop over this, right? Like, you can imagine that I could basically make this be like for auto number next get bits iter or something like that, and then this would be the for loop, and it would just iterate over all the possible bits. So something like that. And this is actually worse for the sets, because the sets are even more complicated. It's a do while loop, so it's do, then we have the iteration at the end, and then the condition. So basically for both I kind of want to have like something like that. So auto set sets number or some whatever, however I conditional the actual generation of the sets. I guess size would be the correct thing over here, and then I need some sort of source or something to that effect, right? Basically to do this I kind of need to write my own iterators, but it shouldn't be too difficult. So this is one thing I want to do. Then the second thing is like putting all these things together, right? Because last time what I did was a lot of work with the Sudoku algorithms, and I have a test that does exercise most of it. But of course, the thing that's kind of missing is like changing the old data structures and classes to actually, use the new stuff. So that has to happen. Other than that, I mean, for this refactoring, okay, let's just have a quick check over here. So okay, so we did the finfish, so this would go away. Yeah, I think we kind of cleaned up this file completely. I think it still has the intersections. Yeah, okay, I don't need the generic non-recursive find anymore. Okay. Yeah, so it still has the intersections. I could also rewrite this a bit. Okay, so this is using another set again. And I wonder, can we... I'm trying to think if I can rewrite this basically so this also is using just a bit set instead of the another set. Because that's kind of the goal of this big refactoring, is getting rid of the sets and another sets out of the code and always just using a bit set. Because whatever we are doing, we should always fit into the size of the bit set basically, right? Okay, maybe okay, let's just write it down. Okay, so switch to bit set, right? Okay, what else? Is this still being used? Okay, so this, okay, this needs to go because this is the old soft finned fish. And we just need to replace it with the new one. And the new one, let's go to our algorithms, takes the blocks and then the function to prune out the things. Ah yes, okay, so this is the thing we are still missing. Okay, so that was... Right, that was the thing I never really implemented yet. Okay. Okay, but the basic idea will be that we do soft finned fish for rows and columns. So get called blocks. Then I will have the prune function over here that I still need to fix. And then the size and number remains. And basically just do this twice for columns and rows. Get row box, right, like that. And yeah, the only thing I need to fix is the prune function. Okay, so I need to remind myself what that one is actually doing, because of course, why would I remember stuff like that from last time? Oh, I just realized I didn't have the chat open. Okay. Hopefully I didn't miss anything. Right. Okay. So we are pruning a number, a block ID I set. Right. Okay, and that I have to do the test. Okay. Where do I... Oh, right here, okay. Am I just being blind? No, so this is X wing. Oh, okay. Further down. Right, here, okay. Right, and the idea here was that I should be pruning out from the intersection of the columns. Jeez, I've forgotten everything again. What the heck? Right. Yeah, so from the correct column, everything that isn't the fin. Wait a second though. Three, four. So this is column 3, but the fin is from... Oh, because it's an intersection with the block. Oh, jeez. Okay, I did totally forget everything again. This is impressive how bad my memory is. Okay. Can I... Right, let's just quickly remind myself. Sure. Okay. So this example was basically we have a 1. We remove the 1 from row 2 and 5, so 3 and 6, I guess. Okay. Except for here and here, right? Okay. So we have this kind of situation, and then we added back the 1 to 5, so here. Okay. Yeah, so then we find the block that intersects with this number. Okay, so we want to find all the columns that then intersect with this block, and as long as the column is not the same column as the fin, we want to remove the numbers from there. Okay. Starting to remember. So how do I do that? Right, in the Sudoku I do have the backmapping from a position. So okay, let's just quickly copy this. Or I guess I can just copy it from the test, right? Okay. Oh, okay, so now the question is, which way will this be oriented? So, if I do get call blocks, then I should be getting rows over here, I think, right? Am I, do I have that correct? Let's just quickly see. Yes, so for rows I get row, column, column. If I have column, I will get column, row, row. Okay. So let's go back to the Sudoku. So this actually was correct for this one. And for this one, again, so this will be rows. Oops, erase it. And this will be swapped. Okay. So again, what we want to basically figure out is get the block that the 3x3 that corresponds to the fin, which is at row and column. So that thing was in block mapping, right? So block mapping for row and column. So this is a vector of blocks. Now I need to figure out which of these is actually the 3x3 block. And how did I do it over here? Wonder what's like the good generic way to implement this. Because really, yeah, so since I don't really tag the blocks in any way, this can really be anything. This can be rows, columns, 3x3s, or some special blocks, right? I could kind of rely on the fact that the way I generate the blocks, and I mean this is okay as long as I keep doing it the same way always. So I can kind of rely on the fact that the third one is always the 3x3. But I'm not super fond of that because it's kind of these like loose coupling things that can easily break if something changes, right? So I'm trying to think if there is a more stable way to kind of pin down that this specific thing is the 3x3 block, or even better, is there a way we can kind of like actually completely ignore that, right? So can we somehow isolate the numbers that we want to remove without even like trying to figure out which blocks we are talking about? So if I go back to this example, right? So for this square, I just get the block mapping, right? So this is basically this block mapping row column that just gives me, you know, this row, this column, and this 3x3 block. Now, the numbers that I want to remove are these two. So if I had a 1 here and here, right? So these two should go. Yeah, basically, oops. Come on. Basically, this should be the result after, you know, these are removed. So how can I identify this square? So this I know that this square lies on one of these two columns, because I know that I'm only removing from columns that are part of the fish. And if it's rotated by 90 degrees, it's the same idea, just instead of columns I'm talking about rows, right? So okay, so I know how to identify the row, the column block, because columns and rows are special, so I can okay, so what I could do, and that would be a little bit robust, what I can actually do here is, since I have get row blocks and get call blocks, so these are just special functions that, because we always have rows and columns in our Sudokus, I mean, that is until now, like, all kind of, you can imagine a puzzle that would be just complete nonsense, but basically the idea is, like, all the algorithms that I'm writing kind of rely on the fact that, in this sense, the Sudoku puzzles are kind of normal, like they have rows and columns, otherwise everything kind of breaks down. The rows and columns don't necessarily have to be, like, you can kind of permute the puzzle in any way, it's just that, like, that's basically just like a visualization of the puzzle, then, you know, it's kind of disjoint from what the actual data is, right? So since I have access to this, I can grab the row block and call block for row and column. So I can just, like, skip over those, and then basically what I'm left with, because again, if you have more special puzzles, there can be more blocks than just the, you know, 3 that are the row, column, and the 3x3. At minimum, if you have diagonal Sudokus, then the middle square of the puzzle, you know, this one, that one actually has 5 blocks, because it's the row, column, the 3x3, and then the left diagonal and the right diagonal. So or I guess the down slope and the up slope diagonal, or whatever, however you want to describe them. So okay, so I can filter out the rows and columns out of here, and then for the remainder of the blocks, what I actually want to do is look at the right, okay, I got it. So for the remainder of the blocks, what we want to do is go over all the elements in the block, ignoring the fin, well, actually ignoring everything that's not on the column that we are interested in. So basically find the elements in the block that are on the column that we are interested in, and technically this, why do I keep pressing the wrong thing? Right, technically, you know, you can have more, because, okay, this wouldn't happen obviously, because you can have, you know, this kind of situation, but like there are situations where you could have like multiple columns involved in the, especially the higher dimension fishes. So then we are basically interested in these 4 squares, right? So let's say that's the situation. So basically find me the interesting squares, and then we just need to make sure that the squares don't lie on the rows that are part of the fish, because those we definitely don't want to remove, because those are, you know, these numbers basically. So those need to stay. And And I think that's actually it. Like, just find me numbers, find me squares that are lying on the columns that are part of the fish for each of the extra blocks, basically, right? And ignore the numbers that are part of the row that belongs to the fish. Okay, I mean, I think that's fine. Oh, but now the question is, how do I actually know that? How do I know the row that I should not touch? Because I know the columns here. Do I also need to pass in the rows here? Okay, maybe I do. But I actually think I should have that, no? Okay, let's see. So yeah, okay, so the iter is actually the set of rows. Okay. Yeah, so let's just change that. And I need to adjust my tests a bit. So now this take two bit sets. And I should also check this bit set as well. Definitely. So we should have only 2 rows. And I think I need to take a short break. There's an insane heat in my room and I need to fix that a bit because this is just not sustainable. Give me a second. 5 minutes break. Okay, so I'm kind of hoping that this isn't too audible on the microphone. Yeah, maybe it is, I don't know. No. Kind of hard to tell. From my side, unfortunately. But yeah, I need a little bit of air movement, sorry about that. Right, okay, so rows. So we should get 2 rows for sure, and the rows we should get in this case should be rows 2 and 5. I guess 3 and 6 actually, yes. Three and 6. Okay. So rows, let's just clean it up. Let's go this calls. Okay. And the second test, the same idea. So now it's inverted. So this is bit set calls, and then we get rows on the other end. Count set should be again 2. And require, so here the columns we are doing is 2 and 5, so 3 and 6 again. Okay. So calls is bit set 3 and require calls is bit set 6. Right. Okay, so this should still be passing now. Let's quickly check that. Come on. No match to call. Sudoku algorithms to teach 138. Oh, I need to change the header, obviously. Right. Okay, yeah. Okay. What exactly are you complaining about? Equals 2. Not like this, right? Okay, yeah, the heat is getting to me. But yeah, now at least the air is moving, so it should get better over time. And yeah, I'm hoping that it's the sound on the stream is still usable and not completely horrible. Oh yeah, and here I have the same mistake. Okay. Okay, so this is passing. Okay, so then back to here. Okay, so we know the rows, we know the columns. So again, this will be rows, calls, and then over here, calls, rows, right. So okay, never mind. So we want go over the blocks. And we want to check that the block can we actually skip the check? So if we just do it for all the blocks, I think it should also work, because there should be no intersection. Yeah, we can just do the same logic for every block, because there shouldn't be a situation where like there would be a number that satisfies the conditions that's in any other block than the 3x3. Okay, so what we are looking for is block. Why is this not working? Yeah, I'm getting the idea that unfortunately Visual Studio Code is really starting to give up on me. Yeah, it's a shame, but I think that's what's happening. So okay, so block here, the blocks. Come on, where are you? Block checker, right. So what can I do? I kind of want to get at the elements. Okay, so I can use the get square, right? Okay. So get the square. I guess I want to go over all the squares and just check if they satisfy the conditions. Right. Right, I basically want to... Can I simplify this in some way? No, because I know the row and column of a square if I get a pointer to the square, because then I can just look up into my big array of squares and I know, you know, what the position is relative to the start of the array. But I guess that's like the only reverse lookup I can do. So okay, well, let's just write this down what I want to do. So I want to do for each square in the block, get xy coordinates if the column is the same as the fin, then skip. If the column is not one of the fish columns, then also skip. So that will basically isolate these three numbers. But we need to be careful because okay, we need to remember that we are looking up the blocks based on this number as a pivot, right? So what we will get is this column, this row, and this block 3x3, right? So in this column, this condition, if the column is the same as the fin, we just skip it. Okay, so we just skip over this one. Okay, that's fine. Then the row, if the for the row, the column is not, so these two would kind of match. So then basically for the column we need to be careful, for the block that represents the row we need to be careful because this one would match. It's not in the, it is in the column that belongs to the fish and it is not in the column that is the fin, right? So we still need to actually filter out the rows that belong to the fish. So if the row is one of the fish rows, then skip. So okay, so it gets rid of this one. So then for the 3x3 block, we again, let's just run through the logic. Oops. So for the 3x3 block, we skip these two, I mean I guess these three, because they are in the column that belongs to the fin. And we isolate it to basically to these three, because those are the only ones that are part of the fish. I mean, okay, so if I just get rid of this, right? And then I remove this one because that one is on the row. Okay, so I think this logic is solid. And we can just do it for every block. We don't have to filter out the blocks and figure out which one of those is actually interesting. We can just apply it the same always. And I just need to be careful that I don't get my XY coordinates mixed up, because this one is like this, but the second call is pretty much exactly the same, except it's flipped by 90 degrees. So again, rows become columns and columns become rows. So just need to be careful. However, the XY coordinates are still the same, like they're still talking about the same thing. Like the first coordinate is always a row and the second coordinate is a column. So we need to be very careful about that. Right. So we, on my block, get row blocks, right. So I need to be very careful. Okay, so the block mapping again, so this was, it's a vector of vector of vector. Okay. So yeah, so this should just be block checkers. Okay, so on the block checker, I need the method. And okay, let's just do it. Yeah, let's just make a very simple get element thing. I will adjust it later, because anyway, like this block checker needs to be cleaned up because we are kind of getting rid of it in the refactoring. But for now, this is okay. Okay, so let's just quickly do this. So, and I guess I should also, yeah, once I kind of put it together, I need to have a test that actually exercises the pruning function as well, because that's one thing that I'm missing in the simple test, in the Sudoku algorithm test, because here it's just hard coding testing. Was this pruning function called with the correct parameters, but it's not actually testing the pruning function itself. So okay, let's write that into the to-do. So right, so test, okay, so actually next to here also test the actual pruning function, because the current tests only test, and I need to turn on wrapping setting. Where do I do that? View word wrap. Right, okay. Also that's the actual pruning function, because the current test only test whether the pruning function was called with the correct parameters. Okay. Right, so this is all good. Right. So back to the Sudoku. Right, so here we do for auto square out of block get squares. So we need to figure out the position of the square, and that's pretty simple. So that's square minus so the x coordinate is square minus let's just okay. I'm getting the feeling that he's getting unfortunately confused. I really need to switch over from the Visual Studio Code. Yeah, I was really hoping that this will work out, but unfortunately too many issues with Visual Studio Code. Part of that is like the code is actually partially broken right now, so I mean it's understandable that it's confused, but it's confused a little bit too much for my taste. Okay, so square minus and I have my squares over here, right? So it's data.data. So this is the beginning of the array of the squares, and if we just, you know, do minus, then we just get the position, and the x coordinate actually is minus size, the divided by size. And this one is the same idea, except we are doing modulo size. Okay, so we have the xy coordinates. So if the column is the same as the fin, so if y equals col, then continue. If y actually if cols is bit set y plus 1, actually if it's not set, right, so cols have the columns that are part of the fish, right? So we're checking if the column is one of the fish's column, and if it isn't, we just continue, right? And then the last step is if rows is bit set x plus 1, and we need to keep doing x plus 1 because the bit sets are ordinal numbers, so starting from 1, and xy are just offsets, so they start by 0. So continue, and the moment we are here, we know that we actually should remove stuff from this particular square. So square prune number. Okay. And again, unfortunately, this is all freaking out, which is very annoying, but yeah, I guess, yeah, I might need to fix this up a bit. Okay, so let me just copy this entire thing and just put it over here as well. So this just all inverse. So if the rows is the same as the fin, if the row is not one of the fish's rows, if the column is one of the fish's columns, but otherwise, oops, I skipped the outer loop. Yep. Okay. So, okay, so this should be row, this should be rows, this should be cols. Okay. Yeah, so this should all be fine. but I don't think we can test it yet. Right, okay, so what exactly we are actually missing here? So our test algorithms are working, which is good. But again, this thing is working. Oh, I'm so used to other shortcuts. Go to definition. Right, so, oh, not this one. What the heck? This one, yes. Yes, so this is working on top of unique block, which is the new class we created over here. So now basically what I need to do is change the Sudoku puzzle to use the unique block instead of the block checker, which will be a big change, and I guess a bunch of things will break because of that, right? So okay, because this is really not cooperating today, I will actually try to switch over to CLion. So let's see, how can we do that? One thing I did actually manage to do is, it's not building right now, but on my local Ubuntu, I actually do have now GCC 10. So it's not as fresh of a version as the one I have on the OpenSUSE server, because this one has GCC 10.2.1 and this is GCC 10.0.1, which might be an issue actually. Damn it, this is so annoying. Like, I need to pick between a fresh version of GCC versus like a good development environment. But again, like I don't, yeah, I really don't understand like why the, like it's getting confused about like includes and stuff. I don't quite get why. Like things build, it's just that the IDE is very confused. Okay. So, unique block. Where is this thing actually used? Oh yeah, it's definitely also used for the one thing we still haven't changed, which was the intersection stuff. Okay. Yeah, this solve intersection. So okay, let's think about this. Can we make this better? Okay, so I mean, can I do this? Split set. I mean, this is basically just a union of all the squares, right? Or am I just being crazy? But this is by number. Okay, so we are basically counting how many squares have that number. Okay, so for that I cannot use the bit sets. Okay, that's definitely the case. I need to use a vector of unsigned. Okay, sure. That's okay. I'm wondering if I can do this better. Probably not. Because, I mean, the two blocks don't really know about each other. But it doesn't have to be an unordered set. This can be a vector. Because it definitely should be the case that I never have an element twice in a block, because that would break everything anyway. So yes, I can change this into a vector of squares. This logic kind of needs to remain the same, like there's nothing I can save here, I don't think. Yeah, and I also think that yeah, this all logic kind of needs to be the same. It can be cleaned up slightly. Okay, so let's do that. Let's move this. Okay. And I also wonder, why do I do this? Why not just have the cleaning logic over here? Because I kind of figure out the set of numbers. Ah, okay. Result definitely should be just a bit set. Yes. Because then basically what I want to do, instead of this for loop over here, over the numbers, I just want to do minus the bit set that I constructed. Okay. No. This is all good. So, but where the heck do I put this? So this will always operate on two blocks. And it needs to access the elements out of those blocks, so it's kind of inherently should be part of the block. Unless I could separate the part that figures out the intersection outside of there. I mean outside of here, right? I could separate that. But it actually doesn't help, because like this full cardinality, right? So yeah, the problem is like this is not a symmetric thing. It's basically one-way check. If I would put it over here, how the heck would that look? I will definitely need like get me the elements function, like there's no way around that if I just have it here. but that's kind of okay. Do I mind that? Like, it does kind of expose the internals of the block, but I mean, that's not a big deal. So maybe I should do that. Then I just can have a free function over here. The one thing that kind of worries me is the directionality of the rule, because okay, so let's just go back to the Sudoku again and let's just clear this stuff. So what this rule in particular does is if you have two blocks intersecting, right? So, and if there basically is a situation essentially like this, let me just quickly construct it. So if I had this kind of situation, so in this column, the one has to be here, right? So, and that basically means the one cannot be in any of these 6 squares anymore. And how do I check that is I check, is the cardinality of this number in the intersection the same as the cardinality of the number in this block? So it's kind of, I'm looking at this column and checking it against like the block blocks it's intersecting with, and trying to figure out if that intersection is forcing any numbers into here basically, right? And if it is, then I can delete stuff out of this block. And of course, like, the moment I do that, like, the rule kind of becomes symmetrical, because then, you know, the one is also missing from here once I clean it. So clearly there are like both kind of forcing the one onto each other at this point, which is actually correct. Like, we are trying to reach this symmetric state. Wondering if I could actually check for the symmetric state instead. And basically figure out like if they are not in a symmetric state, then I need to do something. But there's actually, I don't think I can do that in an easier way. I would have to do the same thing basically. I'm pretty sure. Like, I don't. What would I check for? Like, yeah, I don't really see. Okay, well, let's just do it. So let's just introduce get elements on the unique block. Or I guess get squares. So bit set get squares. Oh, yeah. Okay, so this should be std vector bit set const. So this should be definitely const. It should be no except. Should be definitely no discard. That's kind of it, I think, right? So this is just return the elements and nothing else, right? So let's copy the block checker code over this one. Let's just put it over here. So again, it will be a free function. Solve block intersection. So we have the source block, which is constant. So, and yeah, I mean, this is one thing that will be a little bit more explicit. So, I mean, I already have it as a const method here, but it, yeah. So this is the forcing block. So this is the one that's forcing the numbers into like specific positions in the other one. And this is the unique block, which we probably will be editing. So this one has to be right access. Let's just call it checked. Okay. So we still need to figure out the intersection. I don't think there's any more reasonable way to do this. So get squares, let's just call it, and then checked dot get squares. However, the thing I want to do is instead have this as a vector, so std vector of squares, so bit set pointer intersection and I guess yeah, we can kind of do std max of forcing block dot size and checked dot size, and we might be missing the size maybe. I don't think I introduced that, although I definitely have the information. Yeah, okay. So let's do it. So unsigned, oops, unsigned size const no accept no discard. I guess this could be const expr also. Okay, maybe. Let's do that later. Because I actually think size is maybe const expr on vector. Right. Yes, we do have. So back to the algorithm. Oh, I guess this should be std min, because obviously the intersection cannot be bigger than the small one, right? Okay. Well, and I guess actually this should be continue here. Oh, yeah, this continue won't do anything. Should, right. Yeah, I would basically want to continue the outer loop, but yeah, it's one thing that's kind of missing in C++. Like, it would make things very hard to read, obviously, but it would be like, I keep running into situations that would actually be useful, like being able to jump out of like a different block. But yeah, I can imagine that the code that people would generate using that would just be insane. Okay, so the cardinalities, I don't think I can make that better. That just needs to happen as it is. Right. So actually this should be... Oh shoot, okay. Yes, okay, so this is the other thing I need to expose out of the unique block. And again, I have the information, so this is no discard unsigned, oops, unsigned max. And the important thing here is that this actually should be a number that's stable across the entire puzzle. Because this is really the range of the possible numbers overall. And there could be like extra constraints on top of that. So it could be that like we know that this specific, you know, block can only have numbers from like 1 to 4, while the puzzle can have 1 to 9, right? But that's a thing that should exist besides the max, because you can also have a situation where it can have numbers from like 3 to 9 or 3 to 5, right? And while the number of elements in the block can change freely, the range needs to remain static. And then I guess we could have even like a bit set possible numbers over here, right? So we could limit the set of possible numbers, but we can never change the maximum. The maximum is given by the puzzle, and that should always correspond to the actual dimension of the puzzle. While the size of the block doesn't necessarily. Like we can have small blocks that actually only have some of the numbers, not necessarily all of them. And of course, with those blocks, we need to be careful because, you know, not necessarily all the algorithms we have actually work. Okay, so this should be forcing block dot max and forcing block dot max. And again, this should be a number that's persistent across the puzzle, so we don't really need to do any magic here. Okay, so now I can actually compress this code. So I just realized like I don't really need the intersection for anything. So literally this thing, right? Okay, basically I can just calculate this on the fly, which is so much better. Okay, no, yeah, okay, so this code is starting to look saner. So okay, we go over the elements. So if it isn't the same, then just continue. Let's just go to the next thing, right? Now, if it is the same thing, then we know it's in the intersection. So then we want to do the intersection cardinality. So okay, actually we need a proper for loop here because we are going over the numbers, not necessarily elements of anything. So k, right. So go over the numbers and then int if I is bit set k. Oh, so this should go from 1 to and this shouldn't be I'm editing the wrong thing. Okay, yes, editing the wrong thing. So let's fix that. So this goes over here. Oh, come on. Please ID cooperate. Right. So we want to go up to max. That's what we want. So we want 4k. We start at 1 because we are talking about cardinal numbers. K is less than equal max. K plus plus. So we are in the intersection, right. So we are in the intersection, so intersection, so if I is bit set k, then intersection at k minus 1 plus plus, right. This should be this one actually. Intercard is the intersection cardinality, right. But then we want this same thing for all the squares in this block. And again, here we just need to be careful because, again, this is a directional rule, so we just need to make sure that we... what's the problem here? Run brackets somehow. Okay. So we also want to record the cardinality of like all the elements in here. So yes, okay. And actually I can make it even simpler. Oh man, why did I write this code in such a complicated way? This can be so much simpler. I'm just looking at it and it's becoming simpler with like each thought. Right, okay, so what I actually should be doing, I should have this loop on the outside. So we just go for every number. That's the outer loop. We go over all the squares in the forcing block. We need count is 0. So if this square has the bit set, we increase the count, and then if it's also an intersection with the checked block, right? So this is what ensures that. Then if, okay, what are you complaining about? No, I is Stefan. Oh, yeah. Okay. Oh, come on. I'm really starting to build a certain amount of dislike for Visual Studio Code, I have to say. It's like doing weird formatting on copy paste and getting confused about very simple things. I don't know. Maybe it's me, but it more and more looks like it's Visual Studio Code. Okay. So basically, what we are doing here is, for every number, go over the elements in the block. If the element has the bit set, then just increase the count. Then also check if this is part of the intersection. If it is, decrease the count. And then we are finally getting to the actual meat of the thing, which is if the count is 0, so the cardinality in the intersection is the same as the full cardinality in the entire block, then we actually want to record it. So up here, so what I don't want to store the intersection, but I want to have a bit set for the forced numbers. So over after the two loops, so if count is 0, if count is 0, then get rid of this. Then forced numbers dot set, no, not set, plus equals, no, or equals bit set single bit k, right. Okay, so we start with an empty, so let's just make it explicit, so bit set empty, and it should be initialized with the max, which is the, again, the maximum number we can represent, and this should be fine. What they're complaining about, too few arguments in function call, right, because it also needs to know the max, right? Yes. So this goes over here. Or I guess I can just do, right, I'm overcomplicating it. I can just do plus k, that works. Okay, so after this loop, so we go over all the numbers, over all the squares in the forcing block, and check if it's part of the intersection, and just calculate basically the difference in the cardinality of the number. And if the difference is 0, which means that all the instances of that number are forced into the intersection of these two blocks, well, then we just add it into the forced numbers. And then with the forced numbers, we can actually go and clean stuff. So over here, we basically want to do kind of the same thing as before. So we want to do this loop and this loop and this condition. So for actually yeah, kind of logically actually it should be the other way around. Yes. Okay, so we want to skip over the things that are part of the intersection, but for the squares that are not part of the intersection, in the checked block, we want to do j minus equals forced numbers. So again, this is basically saying, oh, right, this should be the reference. So this is saying these numbers can only be in the intersection, so just remove them from everything that's not part of the intersection. And that should be it, actually. Yeah. Okay, so this all complicated stuff gets squished quite a bit. And we also don't have any vectors. Well, we do have the vector for the card. Well, actually don't, because we don't need it anymore. Right. So we don't have any vectors anymore. We just have one bit set. That's it. And we basically replace the vectors with the count thing. Okay, much cleaner. Okay, pretty happy about that. So I think this was the last thing that we kind of needed to move. It was blocking us from switching over to the unique block in Sudoku. So okay, let's try to switch over this stuff now. So okay, is this actually used outside of the Sudoku square? So block checker, killer, block checker, okay, we don't care about that, that's fine to break. We have some tests and tests, okay, yeah. Right, okay, so most of the stuff is, again, we can ignore the killer block checker because that one, like, that's the entire reason why I started with this refactoring. And the tests we will need to fix, of course. There's there's really nothing I can do about that. Okay, so let's start. Okay, this will be a big thing that will break out was okay, one thing that I didn't do that I really need to do is to add tests, because that's what we have been doing and it's working out fine. Right, so let's add the test cases for the intersection. So solve intersection. Let's just call it intersection 1. Take intersection. And okay, now we'll need to think about the test cases. Well, I kind of showed one of the test cases already. So this is an obvious test case. Like, just start with an empty puzzle. Well, empty puzzle, like puzzle with all the possibilities, right? And basically have this kind of situation over here. And since, you know, the one is missing from these, then it just forces the one over here. We can easily check that. So that's one thing I can do. This also should work for like an intersection of a column and a row, although in that case it's a singleton, like a naked single, right? So if I just draw that, let's just erase this because we don't need it anymore. So if I would have basically this kind of situation, right? So let's just do that. So very quickly. So let's say the row doesn't have any information, and in the column we know that the one has to be, sorry, it's not naked, it's hidden. So this is actually a hidden single now. So we shouldn't really reach the point where we are solving the block intersection. Like, this should be resolved to a 1 just by the sheer logic of, okay, like there's only one possibility for the one to be in this column. But I guess I could just test for that anyway. Like, it's not really, like, it shouldn't break, obviously, right? Like this rule should be robust enough to deal with weird situation like this, even though it shouldn't ever get into this situation. Okay. So I guess those would be like two different test cases. So let's quickly do that. So I will need bunch of Sudoku squares that I can actually share between the blocks, because again, then they need to just be shared. There's no other way to do that. And yeah, okay, I already have the mini test puzzle. That's basically just that. It's just bunch of blocks. Yep. Okay. Well, let's do that. Okay, I should. Let's just add unique block squares. Yeah, let's just generate the squares as well. I think that will be useful later. So the squares are 3 by 3, so we need double loop unsigned. I 0 to 3 I plus plus. Okay, and now we need 2 more loops to actually generate the like 3 by 3 mini square. So for unsigned x, actually we can actually, yeah, we actually know what are the exact ranges here. So the exact range will be, we are going from I times 3 to I plus 1 times 3 x plus plus, and the second loop is unsigned y and we are going from j times 3 to j plus 1 times 3. And what we want to do is over here we want the vector bit set square. Here we want to do square dot push back data x y, and squares dot place back std move square 9u. So this will construct in place the unique block. Oh, actually, sorry, this should be blocks, right? But then squares should be pushback, right? Blocks dot back. So we insert the new block, which is just a unit block, and that one gets constructed in place based on the pointers to the squares that we just generated by this 3x3 small square. And then we just insert the pointer to this block into the squares. Okay, so that should be fine. So then what I can do in this test, somewhere down here, right? So I want the mini test puzzle. Do I also want the expect? Yes, I do want the expect, right? So I want to clear out yeah. So first let's just grab a row and a column and just do the very simple, obvious, hidden single test. So we loop over J, that's fine. But we want very specific stuff, so we want to take row 1, for example, test come on, okay, calls, for example 2, and J, actually this should be, wait, so this should be a pointer to unique. Okay, again, so this, yeah, so this is a pointer to unique block. So then I should be able, okay, I think it's just the ID is getting confused again. I don't know why. So this should be get squares J if okay, if J is not 2, then just remove 1, for example. It doesn't really matter what we actually remove, but this will be a pointer, so this should be like, this should be working. Okay. Now it seems to be happy. Okay. But then basically what should happen in the expect. So okay, we want to remove this also from the expect, clearly. So expect rows 1 get squares, j, also please remove the 1. But then if j is not 1, so this will be manipulating the column. So we want to remove from the expect, so calls to get squares j minus 1, right. So after this, like in expect, we should only have the 1 in the intersection of the row 1 and column 2. And in the test, we should have it in all of column 2. So now, if I run solve intersection, which I'm not getting offered for whatever reason. Okay, it's a bit strange, but sure. So solve block intersection. The forcing block is test rows 1, and the block we actually want to remove stuff from is test column, test calls 2. And after this runs, what we expect is that the test is the same as the expectations. So we just want to do this thingy. We require that all the squares are the same. What exactly are you complaining about? No, that definitely should be defined. Unique block error conversion from CEST. Right, okay, these I need to fix. Small details. Static cast unsigned. Okay, no match for operator on in the test on line 107. What? 107? What the heck? 107. Ah, right. This should be x times 9 plus y. Yes. Still something. Invalid initialization reference of type const. From type right. Where was that? Over here. These are pointers, so this should be the reference to reference. I think. And we have an endless loop somewhere. Oh shoot. Well, it's annoying. Yeah, probably we have an endless loop in the solve somewhere. Okay, so let's just quickly go over the indices here. J, checked get squares, ij. So I mean this will definitely terminate. This will also definitely terminate because these are range loops. So it's probably not this then. So what could be looping? That's so here the J is fine. This is also fine. So did I screw up my initialization in the minute puzzle test? Okay, let's look at it. Did I screw up the indexes somewhere? So this loop is 0 to 2, 0 to 2 over here. This is also this one is wrong, right? Yes. Okay, let's do it again. Still, what the heck? What the hell is the problem? Okay, let's debug. Because this is pretty weird. Okay, so we can easily check this. So do I reach this point? Where's the here, right? So let's continue. I actually do reach this point, so it's not an endless loop over here. Okay, so this is actually fine now, which is good to know. So now I want to set the breakpoints inside of my test. Okay, so let's just stop this for now. Okay. Let's just set a couple of breakpoints and run the debug again. What the heck just happened? How did I suddenly get an error? Number... What? What the heck? Wait a second, why does this... What the heck? Okay, there's something very wrong here. This thing has like a lot of elements. So that would kind of tell me that there's still something wrong in the initialization. So I guess oh crap. Oh, actually, do the other tests depend on the fact that I only had rows and columns? I don't remember. But, okay. I think this is actually a good place to have a short break for me. Yeah, we need to figure out what exactly broke here, but it definitely has to do something with my changing the mini test puzzle. Like there's something wrong with this, clearly, because yeah, like this gets called way too much somehow. Not quite sure why, but it definitely does. Okay, anyway, a short break. Okay. So, again, we're running into some weird situation where there were way too many elements in the set, which is pretty weird. Okay, let's just quickly... I'm not really seeing what could be wrong here. It's probably something very silly. That's usually the problem, and like something that's like obviously shouldn't fail is failing. That's kind of usually what happens. Come on, why is it so slow? Right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. That should all be fine. Yeah, I don't think there's a problem over here. Okay, what exactly is failing here again? Yeah, this is the weird part. It's like the LM is super big for some strange reason. So max is 9. I mean, can I... So this is blocks at position 0. Okay. So okay, so we are looking at rows, and it's basically, is it saying that row 0 is completely broken? Maybe it is. It's quite interesting. So I mean, how would what I'm doing break rows? This is the thing I don't really get. So I have my own vector over here. Square pushback. I am very confused. Okay, let's just... This all... Oh, it's literally like only the first row has like all the elements, everything else is empty. What the heck? How is that happening? I mean, this almost looks like a bug in the compiler. Because we are moving out of this vector. Like if I do row dot clear over here, and the same like here. Oops, what the heck did I just press? Something. I want to go to this test, yes. Like the thing is, if this fixes it, then I'm suspect there's a problem with my compiler, which could be like completely possible. Oh, interesting. So we are still getting segmentation faults. So okay, this is still happening. What the heck? How did I end up? Okay, let's just don't do the move for now. No, it's still a problem. Yeah, it's still happening, so am I just not seeing the bug? I mean, okay, let's just step over this. So, oops. So row is size 9 now, right? Okay. So after I do this, blocks should have one thing which has 9 elements. Perfect. So now if I do continue, so now row has 9 elements, as it should. Then continue, so now blocks should have 2 things, 9 elements, 9 elements. So what the heck is happening? My rows are correct. Quite clearly. I mean, how do I end up with like a completely broken? I'm so confused. Like again, so this is code from Solvefish, right? So I have my 9 blocks. Somehow this one is completely broken. But the blocks I'm passing in are just rows. So I mean, how the heck does this end up so broken? I mean, puzzle rows. Yes, so this is already completely broken. How? Okay, I think I need to sit down on this. Okay, back to my chair. So, somehow, and the weirdest thing is this happens in this specific test, I think. Maybe the other tests don't care, but... Okay, I guess I should also put in the assertions in there, so... So I can definitely test is require over here that rows 0 dot size. Is it like that? No, so the row 0 will be get squares dot size is 9. And this would be something really stupid. I can already see this. Like, this cannot be anything sophisticated, broken. This is some weird typo that I'm not seeing. Okay. Yeah, so this is an insane number somehow happening, right? And this actually, okay, so it's happening for solve intersection, solve finfish, x-wing 2. Okay, is it, are those all the tests? Yes, so it's happening for all the tests, so it's broken everywhere, okay. And it's just rows that are broken. Why the heck would just rows be broken? Like, columns aren't broken, so... What the heck is happening? Do I have like some weird aliasing happening? No, it doesn't look like it. I mean, okay, but very confusing, very confusing. Okay, so this, yeah, because this is not a pointer, this is just this. Okay, so let's just make it other way around, because I actually want to see if it's some shenanigans with the pointers. It is. Looks back. I knew it was something stupid. And of course it is. No, this is so painful. Okay. So, if you didn't catch that, I'm reserving my blocks to have 27 elements. And obviously, if ever blocks gets reallocated, all the pointers are completely nonsensical from there on. Because, you know, there's a realloc, the block in the vector just gets moved somewhere, and all my pointers are broken. And that's exactly what was happening. Oh, jeez. Okay. So now I can kind of move it back into the correct situation. I knew it would be something stupid. It always is. It's never some like actual interesting problem. It's always just some stupid typo or forgotten initialization or something like that. Because that's what coding is all about. Okay, now it should be passing. Okay, we're still getting an error, but now it's actually in the algorithm. Do I just have a mismatch or something somewhere? So, okay, what I definitely don't want to do is how the heck do you add the information into the tests? I always forget. Yes, info, just info. So over here I want to add info. So let's just do I space J, so I at least know the coordinates are wrong. So it's 1, 2. Wait a second. So this would mean that comes to get squares J. So somehow it also removes the number from the intersection. I think that's what's happening. I can check it more explicit. So require that test.data 1, 2. Well, I guess 1 times 9 plus 2 is the correct thing to write. Is bit set 1. Yeah, so in the intersection that should not remove the... Yep, okay, so it's also removing, incorrectly also removing the number from the intersection. Which is interesting because this should be skipping over the intersection. Oh, no. Right. Oh, this is all wrong. Right, this is what I want. Yeah, I want to check if it's inter-intersection, which means I need to go over all the squares in the other block, and if any of them matches this square, then it's inter-intersection. Yes. So if only if not found, then I want to remove this. Well, good that I'm writing these tests because I keep making silly mistakes, but that's usual. Right, so this one we didn't have, and the second test I wanted to do was with the block, right? So it was the, so this was the row column situation, and the second test I wanted to do was basically this thing. Okay. Oh, come on. So if I have this kind of situation, so let's just pick a column and pick a square, right? So let's pick 0, 1, 2, 3. Sure, let's pick the middle square, that's fine. So that's square 4. So 0, 1, 2, 3, 4 is this one. So yes. Okay, so this would be slightly more trickier to construct. So I want to loop. I still want. Okay. So let's pick a column. Sure, let's do exactly this thing. So this is 0, 1, 2, 3, 4, 5. So column 5. So test calls 5 and expect calls 5. Right? Yes. So we want to do get squares j. So from this column, I want to delete everything that's not in this square. So it will be oh shoot, now yeah, okay, so this should be counted from the top to the bottom, yes. So if j is less than 3 or j is bigger equal than 6. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Right. So just remove everything from this column. So minus equals 1. Get squares j minus equals 1s. And now the tricky part for the expect. So in the expect, yeah, basically with the same condition, but we also want to do expect columns oh, but with an inverse logic, right? So else yes, okay, so else we want to remove the stuff from the other columns that are part of this square. So be 4 no 3 4, so 1 0 1 2 3 4 are the columns. So columns 3 and 4 get squares j minus equals 1s. Okay, So we have that. Now we just call it. So we are calling the solve block intersection. So the forcing one is the column. So it will be calls 5, and the test thing will be square, and we said it's a square 4. 0, 1, 2, 3, 4. Yes, square 4. And then we want these things to be the same. So the expect should be the same as our test. So let's see if that works. No, it's complaining about stuff. Okay, assignment into read-only location. Ah, right. The referencing stuff, yes. Definitely correct. Not squares, squares. Yes. Okay, perfect. Now it's passing. Cool. So that means this logic is working. That means I can finally get rid of the block checker, I think. Okay, but let's just first switch over. So this will be unique block, unique block, this will not be a square, this will be a bit set. Let's just get rid of these for now. Okay. I think I'm missing includes, right. So we want core bit set, we want core unique block. Okay, and now this will cause a bunch of problems. So yeah, no longer Sudoku algorithms, we just want to build Sudoku. Okay. Yes, so actually let's just drop out block checker. Yeah, let's get rid of this. And actually what I want to have here, I just want to link in the core library, right? Core and Sudoku algorithms. Yes. Okay, so over here, Sudoku lib, core, and Sudoku algorithms. Was it like that? Yes. So this should get linked against that. And I actually shouldn't have block checker over here, right? And also I guess not square. Okay. So it should be unique block. Yeah, so there's certain things I will need to fix, because right now what's kind of happening is I remove some of the functionality. In particular, I removed the functionality around determining which blocks have changed and which squares have changed. Right, okay, so we don't want this for now. That will come later. Wait, I don't need a get fin anymore, I don't think. So yeah, some of these things can be actually deleted. Test get metrics, maybe. Yeah, we'll see if we want still need it or not. Did that no. Oh, this output is so confusing. Okay, let's try again. Cannot find source file Sudoku algorithms. Yes, because... Right, okay. What actually should be happening is this should go here, because these are not source files, obviously. These are libraries. Okay. That should be better. Let's see if that fixed it. Okay. Square, right, now we are missing square. Indeed, that again makes perfect sense. So just bit set operator, okay. Bit set, sure. Okay. Okay, now we're in the CPP file. So let's go for it. Right. Unique block. Unique block. Has conflict. I don't have a has conflict method on the unique block, which makes sense. Okay, so let's first go for this if I can see something obvious to fix. Changed blocks, right. So this needs to be changed. So I don't track. Okay, bitset doesn't have a way to track if it changed, which I actually think that's correct approach. So what I think I will do is inside of the Sudoku, so I have the block of the data down here somewhere. Here, right. Wait, I already have it. I have the data and data copy. Oh, because I had the explicit data copying. Okay. So we can use this. I basically had the explicit way of like making a copy of the puzzle and then comparing, but I mean that's kind of what we want to do anyway. So I mean, what do we want to do? So let's just loop over all the elements and check in the copy if they changed. So I mean that should be what's happening, right? So data dot size. If data I is not the same as data copy dot I, then okay. And also, why is this unordered set of block checkers? Okay, in this case it kind of makes sense because I want to get each block checker, well this shouldn't be block checker, it should be unit block, but basically I want to get every unique block only once in here. So okay, so this is one of the few places where I actually want the unordered set. Hey, thanks for the follow. Okay, so if the data is, why is this complaining? I thought I had a comparison on the bit said I don't. I thought I did. Let's double check. I think I had the new C++20 freeway comparison. Yeah, it's here. Wait, so what's the problem? No, it was here. Invalid operands to binary expression. What the heck? Oh, but this is clank tidy. Yeah, I think clank tidy is just getting confused. Well, let's just ignore that for now. Right, so if these are different, then basically we want to do the block mapping thingy. Yeah, like this. Oops. Block mapping. So I divided by 9 and j and I modulo 9. Not 9. Size, obviously. Okay. And then we just insert each of the blocks that intersect with this particular change square. Okay, so this should be fine. Let's scroll down with the problems. What is this complaining about? Return a const reference to the column block. Too many arguments. No, that's just a clank tidy complaining. That's not a compilation bug. Okay, I don't need the get fin anymore. and I don't need this. And I can just get rid of all of these. Okay. Okay. Number pos has no member size. So number positions now returns bit set. Yes, that's correct. So this should be count set instead of that. Oh shoot. What is this doing? Get chains. Oh yes. Yeah, okay, this I will need to revisit because I haven't touched this yet in this refactoring. Okay, let's try to rebuild it again. Let's see if some of the things got cleaned up. Okay, yeah, so setup checkers I need to change for sure. Oh, but I don't want the killers for now. Wait a second. Yeah, okay. Let's just get rid of the killer Sudokus for now. And we need to reintroduce them once I am done with the refactoring. But right now it's just screwing things up. Oh, right, okay. We have a bunch of problems in the smart solver. That kind of makes sense. Because this is very dependent on the block checkers. Right, because these are now free functions in the core algorithms. So yeah, so it just takes squares and the size. So it will be solve hidden groups block get squares 1. This should be now correct. No? Oh, and I definitely need to include it over here. That's a good point. Solve Sudoku algorithms. Oh, core / Sudoku algorithms. Yes. Okay. Get squares 1. Okay. Does that work now? Let's see. Okay, I think it's happy with that. So let's just change the rest in the same manner. Okay. Okay, so solve fish. We can still call it on the Sudoku puzzle because then we just do the either way check. But that's so okay. So this is fine. Okay, this needs to change. Yeah, the interfaces are a little bit just a little bit less user-friendly, I would say. I can definitely make a cleanup of that later. It's not a big deal. Yeah, okay, so this piece of code should now be happy, I think, or maybe not. Let's try again. Base operand has a non-block. Ah, okay, so because here we go over all the blocks. I mean, why though, actually? I should be going over the changed blocks. Because, I mean, so if I change something, then I just jump to the top, I get the changed blocks. Yeah, okay, this logic will need a cleanup. I'm just, yeah, it's not as straightforward. It's kind of, it's almost I want to track like the changed blocks on a per rule basis. Yeah. Oh well. I mean, this entire thing kind of needs a cleanup anyway, so not a big deal, but certainly something to work on later. Okay, Smart Solver is still complaining, so oh, because now it's not solve intersection, it's solve block intersection. I think that I changed the name of the function. Solve block intersection, I think it's the correct name. Yes, indeed. Right, okay, now we are back to Sudoku. Okay. Do I have this still? Still have the killer. Yeah, okay. Let's just get rid of this for now. Yeah, this just goes away for now. And yeah, I will need to reintroduce it, but considering that like the entire point of me doing this was I realized that I need to clean the code to be able to do the killer Sudoku at all. Yeah, this is kind of expected stuff happening. Come on. Okay, I don't have has conflict. That's indeed the case. What are you complaining about? Autofly definition does not match. What exactly does? That's clanked ID. I don't believe you, clanked ID. I don't know what exactly is the problem here. Okay, so has conflict. I'm missing has conflict on the on the unique block, which is definitely something I should have. So bool has conflict. So I don't want vector of bools, I want to have a bit set. That's definitely present. We'll start with an empty bit set, so bit set empty with the size of size. Size of max actually, not size. Okay. So now I go over all my elements. Yes. So for lm, let's just do it this way. So auto e lm. So go over all the elements. And right, yes, there should be an outer loop. I mean, I don't even need the bit set. Wait a second, why am I doing this in such a complicated way? So I basically want to loop over all the numbers, yes. Okay, so that's fine. So go from I to max. And I guess I can just simplify it by going 1 to up to max. So check each of the numbers, and for each of the numbers just go over all the elements. Yeah, okay, I don't know why I did it in such a complicated way. This is literally... So we start with, we haven't found the number yet, then if what's my new methods for getting the singletons out of an bit set? It was set, no, value, singleton value, right, has okay. So if it has a singleton value and singleton value is I, then if found, then just return true. So if you have seen this singleton value before, then we have a conflict. Otherwise we want to set found to true. And otherwise return false. I mean, I'm quite puzzled why I did, like previously it was so complicated, I don't know why, but I think this is usually it. So we go over all the possible numbers, right? For each of the numbers we just check if we have found it before, and the only way we can find it is if the element has a singleton value and the singleton value is the number we are looking at, and that's it. I mean, it was so strange. How the heck did... yeah, okay. I really don't understand why I did it in such a complicated way before. Like, this is much simpler. But I mean, I guess that's why I'm doing the refactoring, cleaning up all this crap that I somehow made so complicated for absolutely no reason. Passing... yes, okay. So this is definitely const. It's no except because we are looping over the current elements that we have, so this should definitely be no except. And I mean, it's also no discard because it's a thing that returns something. Like, why would you call has conflict if you are not looking at the result? That's kind of silly. Yes, that should be fine. It's kind of impressive how much weirdness I find just by like going through the code and cleaning it up. Okay, line 4. Oh, okay, this. Goes back to this. Yeah, okay, I don't want the pre-computed areas. That will come later. Okay. Uh, 105. Okay. Okay, what doesn't it like here? So okay, it doesn't actually see the solfish. How? Why? Ah, includes. Includes are missing. Yes, definitely. What happened? Core Sudoku algorithms. Yes. Still doesn't see this, which is suspicious now. I mean, this should be the correct thing, no? What was the algorithm here? Solve fish. Get to 2 blocks. I mean, this is it. Oh, wait a second. The second one shouldn't be const. Right. That's the problem. Why are these actually const? I suspect I just created the const variance. Oh, it's in the header. That makes sense. Yeah, I need to create the non-const variance as well. I mean, technically, this can be actually const because I don't need to change the vector. What I care about is the pointer to the unit block. So actually, this can stay the same. I just need to change my fish. Because yes, so this can be const. This cannot be const, but over here, this can be const, totally. Okay. Oh, come. Is there a way to just... Oh, auto scroll on, okay. So it's still complaining that this doesn't exist, which at this point is pretty strange. Well, now it should be definitely matching, so I don't quite know what the problem is. Sudoku. Wait, why is it trying to look in? That's not correct. Oh no. Now I'm getting screwed by the internal code. Why is... Okay, this is weird. Why wouldn't it like... Yeah, okay. That's so annoying. I wish that would work. So yeah, because this is a template argument on the vector, if I change it to const, it doesn't work. Okay, but I mean, I can leave it the non-const pointer, that's not a big deal. Right, yes, so there's no... Now we are back to the place I was running into last time. Okay, so how do I fix this? This would actually be fixed. Yeah, so this really is kind of pointing me towards adding basically support for iterators. Because once I have support for iterators, this would actually work. I could do position with, so position is bit set here. So my bit set. So what I could do is basically take it. If I support iterators, I just do begin, that works. It returns basically an iterator that's just wrapping a single number. So okay, I guess that's the next step to do then, because yes, I need it for the chains, which I haven't revisited yet. Like, this is another piece of code that maybe could use a little bit of a cleanup. Okay, so let's think about it. How do we make this work? So I kind of want a wrapper essentially. Like, I want to take a bit set and I want to convert it into something that has begin end and provides it an iterator. The reason why I want to do this way is because there are two different iterators that I want to have. One of them is iterating over the set bits, and the second one is iterating over the sets. So it kind of corresponds to the two methods that I have. So there's like the next set and next bit, right? So these are two different types of iteration. So I kind of want to have two different wrappers for this. Okay, so I think that's the next thing to do today. Let's quickly, yeah, I don't even remember when I last time did do iterator. The tricky part is this recently actually changed. But this actually looks, it's using the new stuff. These type defs. Let's just, okay, let's have a look. Trait based iterator C++. What the heck is a continuous iterator? So I mean, this would be an input iterator, right? I think that's it. Okay, yeah, I think it's what we want is an input iterator. Okay, let's take a short break and then we will look into these iterators and how to actually do C++20 iterators. Because yes, there were things that changed. I don't think actually it changed in C++20 because this is just the concept. And I don't think I care about the concept itself when I'm implementing an iterator. But yes, I will need to double check that. So yes, 5-minute break and I will be back. Okay, so time to figure out how to write custom iterators. So I think what will make the most sense is actually for me just to write like a small piece of code. Okay, let's just do new file, test.cpp, and let's just splice it over here. So add executable test iterator test.cpp, and this thing should really be linked only against the configuration. So test iterator, project options, project warnings. Right. And let's just see if this compiles. That goes away. This should build. Damn it! Why is this keeps? Okay, but I should have. Right. So this exists, and when I run it, it runs. Perfect. Right. So now we have a small main that I can play with. And now I just need to figure it out, right? So C++20 custom iterator. Let's see. How to correct? I don't know, that's an old one. Well, okay. So I guess what makes sense is to do search, not this one. Ah, so many misclicks. This thing, right? Past year. Okay. Introduction to iterators. Right, okay. Okay, so now basically we are supposed to use the traits instead of just inheriting from iterator. You just do this. So okay, but we need two things. So we need the iterator itself, but we also need the wrapper, because the wrapper is the thing that exposes the begin and end. Okay, so basically let's kind of, I will just create like a simple like an equivalent piece of code. So let's say this would be our, equivalent to our bit set. So let's say it just stores some number, and then we would have the wrapper. So this thing needs to expose some sort of begin and and then I need my iterator, right? So struct input iterator, And I guess now I can look up yeah, I suspect there will be a lot of boilerplate to deal with. So let's go to CP preference again. So this was iterator. Input iterator tag. It's interesting, like they don't really describe how to make custom iterators in here. It's basically code that's using iterators, how to write that. So, I mean, so I will have two iterators. One of them will be the set iterator, right? So set iterator, and then the struct bit iterator. So both of them will be std input iterator tag. I need the iterator header for this. Okay. So this will be unsigned, 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 unsigned. Right, okay, but this one actually will not be unsigned. This will be actually the entire thing. So this will be S, right? So S. Okay. So then I need a bunch of those operations. I think I need the same operations as on the iterator in the old standard, right? legacy. Okay, so these things need to work. Right. So we definitely okay. Shoot, how do I do this? I guess I can use this. I should be able to just use the default. Let's see. Yeah. The default comparison from C++ 20. So where the heck was it? Okay, yes, this thing. Right. So what do I actually need in the iterator? I guess just the value. Okay, then I need the plus. I need operator plus plus. And the inverse one. So I need both of them, right? I need the dereference, which will give me the value. Operator dereference. That should actually be it, right? And I mean technically, so this should be, you know, value type. Why is this complaining? Yeah, whatever. Okay. Alright. Actually, let me just pull the bit set over here. So this would be include core slash bit set, and let's just link against that. And let's just try to straight up make that work. So this needs core. Okay, so yeah, okay, so the complainable operator, right? So how do you do? I don't remember how do you do both of them. It's like one of them takes an int, extra int or something. Right, yeah, so that it takes an extra int, okay. So this is the postfix, right, and the prefix is without that. Right, okay. So this one should return bit iterator plus plus, and yeah, let's just make these three functions so it's clear. So bit iterator, oops. Reference to bit iterator. So next bit, what was this thing called? It is called next bit. So I mean, what's the issue over here? Okay, I definitely need a bit set here, and unsigned current. Okay. So next bit on set current, but on it.set it.current, and so bit iterator right. So I want to create a new one. Wait, so is this the prefix or postfix? I keep forgetting. So this is the prefix one. So in the prefix one, I'm actually returning. Okay, so in this case, I'm just returning this. So actually, what's happening is it dot current equals next bit. Okay. What? Okay. Weird stuff is happening. Okay, and the postfix one is bit iterator operator plus was bit iterator it and right posted, yeah. So this is the postfix one. So the postfix one returns the current value. So what I want to do is bit iterator result So just copy it, then do this, and then return result. Okay. We have it in the Sudoku namespace, or where does this live? I keep forgetting. Yeah, just Sudoku. So yeah, this is in this namespace, this is in this namespace. Okay. So I think I should be just taking a const reference to this. So okay, when this is constructed, bit iterator const bit set reference, and I guess that's it. So I need to do set my set to set, and then current will be 0, right? That's how it works. Let's quickly check. Current +1, while set is bit set. Yeah. Yes, that's what I should do. So I guess I need bit iterator const bit iterator default copy constructor. Don't really have an empty constructor, I don't think. Okay, let's see if things explode again. Yes. Oh, the reference should be just current. Okay. Oh, so this should return a value, not reference. Yes. Okay. So this seems correct. Okay. So this should be good enough for the iterator. Thanks for the follow. Right. I still need a wrapper. So the wrapper. Right, so this will be the bit iterator something like make, well, there's this thing for like the back inserter, right? How does that work again? Yeah, so this returns an iterator from a container. So I kind of want the same thing. I want bit iterate. So this will oh shoot, how do I do this? Bit iterate. So I definitely want to do it on top of the bit set, right? Like that's definite. Bit iterate on top of the bit set. But again, I just want the const reference. So private, oopsie daisy, private. Then, right, so then I just do this. So my begin will be bit iterator from the set and a 0. And my end okay. What the heck is my end? Okay, I need something. Well, the weird thing is I think my end miss is also my... It's also the same thing. Because the way I generate the bits, basically I end it with returning to the same situation, like it's a loop essentially, right? But I actually don't know if this will work. Wait, why is bit iterator not liking... Ah, well, okay, I guess this is okay like this. Well, this will be interesting. So let's just make bit set max value, sure, let's do 9. Well, let's 9 is fine, that's okay. Bit iterate set okay, so it doesn't like this because cannot be referenced as a deleted function. Wait a second, what? Oh, bit iterator. Wait, why is that a deleted function? I have the comparison operator from C++20. What? Okay, this is getting quite strange. Okay, let's just see if this completely explodes or not. Okay. Use utilities, yeah. Okay, this is something I seriously don't understand. So, bit iterator, const bit iterator. Because the default definition will be ill-formed. Cannot default compare. Wait a second, why couldn't we do that? We can definitely default compare bit sets. I mean, bit sets are comparable, so why? Is it because it's a reference? But why? Okay, this is some weird corner case I'm running into, I suspect. Okay. Well, damn it. I guess I can work around this pretty easily. I can just do so this will not be a default. So if the sets are the same, then just return that, otherwise return not quite sure if that actually makes sense, but it should work now. No much for operand as a bit iterator and bit iterator. I mean, I just added a comparison here for bit iterators. Like, why is this not working? This should be completely okay. I really don't see a reason why this would not work. could be some C++20 weirdness that this is a bit too fresh. I mean, I can... Okay. Let's just put this to the side for a bit and let's just do this explicitly. So bool operator less than const bit iterator run hit side const return. And I guess let's just make it exceedingly simple. I just ignore the sets completely. And I guess we need non-equality. Bit iterator, right hand side. Okay. Yes, but of course actually need to do the correct operations. So are you still complaining with me manually defining this? No, it's not complaining. Okay. But it's also not doing anything, which is annoying. Okay, I suspect the problem is that because the begin and end are the same, it will just not print anything. So, okay, I kind of think I need to have like a sentinel value that represents the end. Bit set. Something like std numeric limits unsigned max. Like this is a little... I'm not super fond of this, but I guess or I mean technically I could always just use the like max plus 1, just grab it off the set. I mean, okay, so if I completely remove this, check, just like return iter, right? Then what I can have in my iterator over, not in my in my wrapper actually, yes. So what I can have over here, I still need to change my iterator because of that. Right, so go to definition. Yeah, because I need to actually set the value. Right, so in the wrapper, start with a 0, yes, but this should be set.max plus 1. Okay, so that will be our sentinel value. So now it should actually iterate over the... Yes. Oh shoot, no. Wait a second, how the heck does that happen? Right, my begin is wrong. So okay, so this is shoot. Okay. Right. Basically. Okay. Slightly more complicated. Oh, jeez. And this wrapper will be a little bit messy, I'm realizing. But I don't really see how to make it easier. Okay. So basically, I want to start at the first valid bit, which could already be end, which is fine because in that case it will just not print anything. Yes, okay, so this should work fine. Yes, now it goes over the bits. So now if I initialize it with something different, so like 2 so this is a set with the maximum 2 bits. Yes, perfect, this works fine. So let's do a set 9 3, so this should be the first 3 bits set. Correct. If I just do empty, this shouldn't print anything. Yes, that's fine. And if I do like a single bit of size 9 and the bit I want to be set is bit 5, it should print 5. Yes. Okay, so this wrapper is working correctly. Okay, so the wrapper, the begin just gives us the first set bit, and then the end is the sentinel just beyond the max, and we just in the iterator we just iterate over the elements. I still don't know why this is not working. Like this should be working perfectly fine. Like why does it require me to have it still doesn't like it. I don't get it. And I mean, really, the only thing that makes sense here is just this. But why does it complain about the non-equals? I don't understand. Like this does look like a compiler bug to me. Yeah. No match for operator not equals. But I mean this. Yeah. I don't know. Bit iterator. That should actually be. No, this needs to be auto, yes. Yeah, I don't know why this doesn't work. Okay, let's... Well, I will not be able to test this in Code Explorer, I don't think. I guess I could minimize this example a bit. Right, so I could make it just iterate from like a number to a number. So okay, let's go to Code Explorer. Compiler Explorer, I meant. Getting tired saying silly things. Right, okay, so I still need include iterator. And yeah, let's just make this the simplest way possible. So Okay, this will be our iterator. This will be our wrapper. So the wrapper will be auto begin return 0, auto and well, return unsigned 0, please. Return 10. Oops. And the iterator will be basically the stuff that I did here. Sure, input iterator is fine. Unsigned, 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 everything is unsigned. Then I just need unsigned current. Oh, okay, so this should actually return it like this. Okay. Come on. And then this thing. Right, so GCC trunk and int main return 0, but what I want is 4 auto x wrap right, like that. And okay, and then here I need an IO stream. So okay, this should be it. Okay. No match for... Okay, what exactly is the problem over here? Crap. I mean, this is correct. I'm not quite sure what it was. Right, okay. I still doesn't... Damn it. So, okay, so this one return current, so it's simply this, and operator plus plus, auto operator plus plus, return this, but I need to increment current. No match for non-equals, yes. Yeah, okay, so this is... Okay, so what does Clank do when I do this? Because this really looks like a bug to me. Or maybe I'm just misunderstanding something fundamental somewhere, which is always possible. So trunk... oh wait, this is... Cannot use built-in operator because... Strong ordering... Oh, need to include compare. Is that what was the problem? Yes, that was the problem. Ah, okay, like this diagnostic is annoying. Compare file not found. Well, okay, that's amazing. It tells me I should include compare, and when I do, it tells me that compare doesn't exist. That's brilliant. That's just amazing, I have to say. Like, that's... Oh, wow. No match, yeah, okay. Yeah, so the problem is Clank doesn't have compare, apparently. No, wait. What? Ah, sorry, I need to make everything small because I don't quite get what... Wait, what? Where do you... There's a... Ah, damn it. Not that... Oh, output. Run the compound output. Compare file not found. Okay. So, Clank doesn't have compare. We know that now. GCC... does have compare, but still doesn't like this. Yeah. Okay, so I think this is just like too fresh of a functionality. But weirdly enough, like, the very interesting thing is, it's only complaining about not equals. But I guess that actually makes sense, like, why would it... It doesn't really need to compare for less than, right? Okay, so if I do it 1... Okay, so it's... Let's just have a couple of variables here. So if I do x less than y, so I actually do have less than. And I suspect I have... Oh, I don't have equals. Oh, so it's just missing equals and not equals. What the hell? Okay, so yeah, that really looks like... I'm just using too fresh of a functionality. And yeah, sorry for like making the code so small, but yeah, I was just trying to fit everything on the screen. Actually, I can make it work like this. Yeah, so the problem I'm running into right now is basically I'm using the C++20 comparison operator that comes from the compare header. Let's jump to here. Damn it. So I'll find it like this. No. What the heck is this called? I know that this has like the has like a specific name, this operator, but yeah. But yeah, the problem I'm running into is that for whatever reason, like if I define this, and I can actually have the default one now, right? It's the same result. So if I define this operator, what the heck? Expected? No, it's okay. Wait, it actually works with the default one? What? So is it failing now because I don't have the default one? Okay, let's see. If this is the problem, then my head will explode. Oh no, so here it cannot work because I have the reference, yeah. Oh, damn it. Okay, so this is really not working because I have a non-default comparison operator. Oh, the joy of living at the edge. Yeah, this is too fresh of a GCC build, I suspect. Yeah, okay, so I need kind of roll back to this kind of setup. I mean, optimally this would work, I wouldn't have to define this. But unfortunately, yeah, with the old operators it works just fine. It's just that, yeah, basically this is... Oh, this is so annoying. Yeah. Okay, so but for the bit iteration we have what we wanted, which is good. Now I just want to make the same thing for the set iteration, and that one is slightly more complicated. Okay, so the wrapper for this will be set iterate. Set iterate. Oops, iterate. And this one will take unsigned maximum value and unsigned bits. So the maximum value, so this defines the size of the, well, I guess I should call it size. So the size of the set, and yeah, the problem is both of them are kind of size. Yeah, okay, so the size of the set is actually the second one, yes. So this should be size. And this should be range, I guess, is the most descriptive thing I can put there. So the range is basically the range I want to iterate over, as in like the minimum and maximum bit that I would want to look at. And then the size is just the number of elements in the set. Okay. So let's do that. So what I want to remember is the range. Yes, so this will be just two unsigns. And unsigned size. Can't spell again. Or can I? No, this is correct. What's the problem? I don't know what's the problem. Oh, the problem is here, right? So range is range and size is size. So then the begin is return bit set range size and end. Okay, so this will be slightly tricky. So the end so what do I do as a sentinel value? Now this gets very tricky because I kind of need like a special bit set that kind of represents like a no value essentially, right? Because the problem I'm running into is if I basically tell it give me all the sets that contain 64 bits, that should still work, and it should return the one set that contains 64 bits, even though this is like the maximum number of bits that our bit set can represent, right? Because I'm using 64-bit integer as like the representation of the bit set. But again, if I just tell it, you know, back in end, just give me the one set, so I wonder, should I just make like a set with 0 things in it, the invalid value? It is kind of what I have been doing. Like a bit set that has no bits set. In the context of Sudoku, is like basically an empty is kind of nonsensical. I mean, with this I would kind of need to handcraft my comparison operator so it works. But from like it makes sense perspective, this does kind of make sense. Because then in the iteration I can just have it return empty the moment it just goes over. And yeah, I just need to make sure that the comparison actually makes sense. Okay. So, okay, so but this, yeah, okay, so I'm doing it slightly wrong. Well, actually very wrong. So the set iterator. So the value type will be a bit set. So this will be Sudoku bit set. Difference type, sure. Although there's no difference. I guess this should actually be void. Because for an input iterator, the difference doesn't make any sense. I hope it can live within void here. Okay, so then the thing I need to store is my current set, right? So this will be Sudoku bit set current. And then I need my operators again. Right. So, oh, and I will definitely need a constructor from a bit set. Yes, so this will be very simple, just current is the set, that's it. Okay, so comparison with another set iterator. So if RHS dot current dot count set is 0, then always return true. So anything compared to an empty is always smaller than an empty. Otherwise, just return the basic comparison. Then equals will be just equals, that's fine. Set iterator. Non-equals can be non-equals, that's fine. So plus plus. So what I will want here is Sudoku next set. Okay, but I will need to adjust the next set. So where was that? It was in the bit set, right? So the special thing, okay, references, right, oops, right, I actually do iterate until empty, so this is yes, okay, so this is actually correct. Cool. So then this thing will work just fine. So just it current equals next set it dot current. Okay, and this one result it next bit next set it set like this, return result. That should all be fine. Okay, what's the problem? Oh, it's just crank tidy being silly. Okay. So if I do Sudoku for auto set set iterate with range 9 and number of bits 3, okay, let's just finish writing this. stdc out set dot debug string std end line. Okay, let's see what the actual compiler is saying. Okay, invalid initialization. Oh, yes, these need to change, obviously. Set iterator. I don't have a copy constructor indeed, so set iterator const set iterator equals default. Yeah, the default copy constructor is good enough. Okay, let's see again. Declaration of set. Oh yeah. Okay. Let's just call it S. That's fine. No match for operator plus plus on a bit set. Right, because this should be set iterator set iterator. Okay. Okay. 1, 2, 3. Yeah. This looks correct to me. Cool. So we have our iterators. Perfect. So then, instead of the crazy do while loops, I can just do range loop, and it should just work. I might want to. No, I think this is all fine. Reference. Yeah, I wanted to play with this and try to see how exactly the optimizations end up working, because there could be some extra copies happening, but again the bit set is just 2 integers basically, so I mean I don't really have to care about references versus copying, honestly, because it's kind of the same at the end. It's just basically 64 extra bits, so 8 bytes extra that might get copied around. So I mean it could hurt my cache performance, but I think this should be all optimized out. And I mean I can retest that in the compiler explorer if I want. But looking at the time, I've been streaming for a long time today already. So it's definitely time to finish. We did make a lot of progress, so I did manage to clean up a lot, like a big chunk of the Sudoku class, and we made a detour into basically changing the way I generate the different bits that are set in a bit set and different sets using a bit set using iterators, and that's currently implemented and it seems to be working fine, except for some minor issues with weird C++20 operators not really working as intended, but besides that detail, everything seems to be fine. So I think tomorrow I will just clean this up a little bit and we can just port it back into the main bit set. And then I can continue with the refactoring. Then, the something.begin and whatnot will just work. And we can just move on. And I can also, again, further simplify the code by removing the weird loops that we are currently using. That's kind of hard to understand. Okay, but it's definitely enough for me for today. I've been streaming for ages and I'm super hungry. So see you all next time. And next time again is tomorrow. The same time, 2:30 p.m. Central European time, and whatever that translates in your time zone. I'm sorry, I don't remember all the time zones. But yeah, if you have any questions, you can pop into my Discord or my YouTube channel, and feel free to ask questions, or see you tomorrow.